Good evening, everybody, and thank you to all of you who are here in person and also to all of you who are on the webinar. This is the last seminar in our Spring 2024 series for the Science for Community series. Thank you all for coming to this and in any of the previous ones as well. So, as I mentioned last week, it's that time of year again, and our dolphins are back in the bay. So I really want to highlight again our Dolphin Watch program. So if any of you are all out on the water, please download. It's in the Android and Apple version. It's an app on your phone, and anytime you're on the water or near the water and you see dolphins, log them, because we really need this data. I mean, this is a community science project, and you help us understand when the dolphins are coming into the bay, where they're going, what they're doing, and this really helps us understand these really, important and iconic species. So this is our 7th year. There's leaflets out in the hallway, so please feel free to take one of those, and it has a QR code for the app. And I just want to highlight, we'll be continuing these Science for Community series. We do them every spring and also fall. And so keep an eye out for that announcement. But I would also like to welcome your input for these. We have a lot of great scientists doing a lot of research, not just here in the Bay, but globally, addressing a lot of different environmental problems and providing solutions to managers and agencies and policymakers. So if you have any ideas on any topics that you would like for us to talk about, that are addressing any environmental concern or issue that you've read about or you want to hear a little bit more about in detail, please email me, and I'll be happy to try to identify, the experts that can talk to that. So please, your feedback is important as well. So with that, I'd like to introduce Associate Professor Chris Rowe, who is a herpetologist. His area of expertise is in studying how physical and chemical aspects of the environment affect animal function and ecology. And this is especially for species such as amphibians and reptiles. So this includes work, of course, on our iconic diamondback terrapin. I know some of you are from Asbury are probably very familiar with Dr. Rowe and all of your efforts. Thank you for helping this iconic species. Chris has conducted a lot of work looking at the impact on things like climate change, water quality, habitat loss on these species. So his area of expertise is in physical ecology, ecotoxicology, environmental health, and specifically, again, herpetology, so working on the amphibians and reptiles. So with that, I will hand over to Dr. Chris Rowe for his presentation here.
Thank you.
Okay, thank you.
Hi, folks. Thanks for coming out. And hi to you online, wherever you are. So typically when I get up here and talk to you guys, I talk about things that I've been working on myself. Tonight, I'm actually going to talk about some things that a lot of other people are working on. I'm going to be talking about biodiversity. In fact, I'm going to be talking about the situation we're facing today with respect to biodiversity in our modern world. As I put together this talk, I realized that my topic is biodiversity, but most of what I'm going to talk about is extinction. And that's because extinction is the downside or the opposite of biodiversity, but it's a situation that's happening at a high rate currently. So we're familiar with the adage, variety is the spice of life. More different things are better. And that's true in an ecological system as well. Typically, all else being equal, a more diverse system is a healthy system or a healthier system. And so what we as ecologists look for is we look to conserve and to preserve the biodiversity of our wild systems so that they operate the way that they should, and so that all of the connections work as the way they should. So when we're talking about biodiversity, we're simply talking about the variety of living species. Currently, we know specifically when talking about animals, that there are about 2 million species that have been described that are living today. Most of these are invertebrates. Okay, so we tend to be biased somewhat toward vertebrates, and I'm guilty of that myself in many cases. But really, most of what's out there. I'm sorry. Share your screen. Share my screen. Oh, gotcha. Sorry. Okay.
Oh, gosh, I'm doing. Oh, just give us a couple minutes. Everybody's gonna figure out how to do this. Why is that not working? That should be working, yeah.
Okay, thank you. All right, sorry about that, folks. Anyway, so there are quite a few species out there that, are we okay, Tom? Thank you. All right. Currently, we know of about 2 million living species of animals. There are also about 391,000 species of vascular plants out there. And as I mentioned, most of the animals are invertebrates. So there are oftentimes animals that we don't think that much about. They're incredibly important to a lot of systems. I'm not specifically going to talk about invertebrates today, except for a few examples. But they're following the same trends that we're seeing in a lot of the vertebrates. While we know of about 2 million extant animal species, there are probably 3 or 4 times that many actually out there. We tend to be really good at finding big stuff and stuff that lives in places where we go a lot. But little stuff and stuff that lives in places we don't go very much tends to slip past us. So there are estimates out there that say there are probably around 8 million species of animals out there today. Many of them, again, in places where we haven't looked, or we've missed them as we've been looking. Areas like the deep sea, for example. So biodiversity is a good thing. But biodiversity is lost through extinction. So extinction is the loss of species. Extinction is a final event for a species. So you've heard the phrase extinction is forever. Extinction is forever. By definition, a species that is extinct is gone. It will not come back. Okay, it's natural. Okay, so species go extinct. Species have lifespans just like individual organisms have lifespans. And I'll return to that in a minute. But when we look at the history of the Earth has been around for about 4 billion years, and for the vast majority of that, life has been operating, okay, oftentimes in a very simple manner. But really about 500 to 600 million years ago is when we saw the diversification of a lot of the multicellular complex animals and things that when we look around today and we see animals that we think of as animals, they've been around for quite a while. Throughout that period of time, there have been way more species on Earth than there are today, and most of them are extinct. Okay, there have been orders of magnitudes more species in the past than there are today, and they've gone extinct through natural processes. On average, species go extinct at a rate of about 1 to 2 extinctions per million species per year. So that's considered our background rate. When we start seeing rates above that, then we start to wonder if something might be wrong. From the fossil record, we know that the average species lifespan is somewhere between 1 and 13 million years. Some of the longer lived groups are some of the smaller invertebrates. We see with mammals, for example, the average species lasts about 1 million years. which in a geological sense really isn't that long. But there have been times in the Earth's history when extinction rates have been incredibly high. And these are what we've classified as mass extinction events. And these are periods of time when, during a short period of time, in a geological sense, more than half of the species on Earth, or at least more than half of the multicellular species on Earth, disappeared. So throughout the Earth's history, beginning about 445 million years ago, and as you can see, from time to time since then, there have been these major catastrophic events that have occurred due to geological processes on the Earth, oftentimes massive volcanism across large areas of the Earth, and producing a lot of toxic compounds. Things like asteroid impacts. We're all familiar, I think, with the most recent mass extinction event, and that was the one that took out the dinosaurs. And it's been attributed to an asteroid impact, and that was a major cause of that extinction event. As I'll mention in a minute, there were some other things going on at the same time that really didn't help the dinosaurs out very much. So let's take a look at this most recent event just as an example. So this most recent mass extinction was at the Cretaceous Tertiary boundary. It's often referred to as the KT event. The K doesn't mean somebody misspelled Cretaceous. The K is from the German word Kreta, which means chalk. And it refers to the limestone deposits that were present during that time. Well, there were two things that happened during this period around 66 million years ago. First of all was this asteroid impact. So this occurred at the Yucatan Peninsula near Chicxulub, Mexico. And the result was a crater 120 miles deep, or in diameter and 12 miles deep. So it was a massive collision with the Earth. The immediate result was filling the atmosphere with a tremendous amount of dust and debris that lasted for quite a while, blocked the sunlight, and the sunlight is blocked. We lose the base of the food chain, or the food web. So that was a major impact, of course. The animals are reliant on the plants for food, and when the plants don't have light, the whole system begins to fail. At the same time, there was a massive amount of volcanic activity occurring on the Indian subcontinent. Now, 66 million years ago, the Earth didn't look the same as it looks today. Okay, the continents, as we see them today, were not in the same place then. So at 66 million years ago, the Indian subcontinent was moving northward to eventually collide with Asia, which would form the Himalayan mountains. But at this point, 66 million years ago, was passing over what's considered a hot spot in the Earth's crust. And that's an area where volcanism is highly likely due to a thinning and to some actions in the mantle beneath the crust itself. So during this time, there was a period of about 30,000 years of intense volcanism that covered almost all of India. And so this is producing large amounts of gases, things like sulfate, sulfur dioxide, which when combined with water and water vapor, turns into sulfuric acid. So we had acidification occurring in the terrestrial habitats. What plants made it through that period of darkness were being hit with acid from above. The animals were being hit with acidification. The aquatic systems were being acidified. So these were two massive events. There's still a record of the Deccan traps, which is what we refer to the Indian volcanism, and it still covers, as you can see in this lower figure, a large part of India, and there are lava deposits over a mile deep. So it was huge. Okay, the point I'm trying to make is that typically in the past, when extinctions occurred, on these mass event levels, they occurred because of really big events, big things happening from the Earth itself or from things outside of the Earth, but things that were major global changes. So we looked at, we saw this asteroid impact plus the volcanism. We see the changes to the food web, to the biogeochemistry, and the, in sum, we see then the result is about half of the biological families, about 75% of the species on the Earth were eliminated within a fairly short period of time. That's not all. Most of the large animals, terrestrial vertebrates over about 55 pounds, so over about the size of a medium dog, disappeared. So the size, the genetics that were producing these large animals were lost during this period. Well, so extinction from a biodiversity standpoint seems to be a bad thing, and it is if you're a member of the species that's going extinct. However, if you are a species that survives a mass extinction event, you might benefit because extinctions open up niches that other species can adapt and radiate into. So, for example, if we go back to our KT situation 66 million years ago, most of the mammals, or at least a large number of the mammals, were really small fossorial animals, basically spending their time hiding from the dinosaurs. But we had the KT event, we lost all of the large terrestrial mammals, and lo and behold, we get us only 58 million years later. So the point is, we can be really happy that that asteroid hit. Many of us, especially when we were kids, we loved the dinosaurs, and we're really sad that the dinosaurs aren't around. But I would argue we should be darn happy that the dinosaurs went extinct, because there would not be any of us. So here we are today, 66 million years later, and we're starting to see an increase in extinction rates around the globe. And these extinction rates are almost entirely tied back to the actions of one species, and that's us. And so that's where I'm going to spend most of my time today. So there's been work looking at thousands of species through monitoring and modeling efforts that have shown that there have been recent declines in both the abundance of the number of animals out there and the diversity, or the number of species out there, for both animals and plants. Recently, some work came out showing that in the 30 years between 1970 and 2000, there was a 40% decline in the abundance of vertebrate animals worldwide. That's a shocking number. Even the mass extinctions that we see in the past, we're working on a time scale somewhat longer than 30 years, right? So there have been some massive changes that have occurred very recently, and chances are they'll be reverberating throughout the animal kingdom perpetually. So going back to this idea of background extinction rates that I mentioned before, we look at the extinction rates that are occurring today, or recently, relative to what they should be based on that background extinction rate. We see this tremendous increase in the number of animals going extinct relative to what should be based upon the historical records. So that leaves us with the question of, are we entering another one of these mass extinction events? This could be addressed from several angles. But I'm going to come at it from the scientific angle, and the scientists, by consensus, largely have agreed that extinction rates are at a point now where a mass extinction event is possible, and some will argue that it's probable. These are just a few of the peer-reviewed studies I've run across have been published over the past decade or so, all purporting that the future is looking really bad in terms of biodiversity and the possibility of major extinction events. Some of you may be familiar with the fact that this has been named the Anthropocene event. Anthropocene referring to anthro being human, indicating that this is a big change in biodiversity of Earth driven by human activities. So what is it? What's going on today that could be leading to these extinction events? Well, there are quite a few things. Probably across the board, the biggest problem facing diversity today is loss or change of habitats. Habitat alteration, habitat destruction. We see things like agriculture, slash and burn, the removal of rainforests and forested lands, turning into monocultures and into grazing lands. So we lose the functions of the forests and we lose the communities that lived in those forests. And we end up with areas that are occupied by very few species with little ecological importance other than feeding us. Things like mineral and energy extraction, mining. This is an example of mountaintop mining. I don't know if any of you are familiar with this, but it's a crazy thing that goes on frequently where actually the tops of mountains are removed. So that removes not only the mountain, but the diversity that existed on that mountain. Development. Everywhere we go, we leave our mark. Right? We alter the environment to fit our needs, and when we do that, we remove it from being useful for many of the animals out there. And other things that we do. For example, we destroy habitat unintentionally when trying to accomplish other tasks. This is an example I thought was rather stark. This is showing the deforestation patterns in Brazil over about a 70-year period. So you can see in the 1950s, Brazil was basically forest. And we see by 2020, only a small proportion of the land is still forested. That's important for a lot of reasons. Selfishly to us, the rainforests are producing a lot of stuff that we need, like oxygen, and are sucking up a lot of stuff that we don't want out there. It's like carbon dioxide. So as these forests are declining, their function, not only locally to the communities that live there, but to on a global scale, is being disrupted. I ran across this aerial view. This is from Brazil as well. And this is the change in the forest over about a 30-year period. So this is a fairly rapid and very radical change to the environment out there. Harvest. Well, harvest is another way that biodiversity is being declining because there are certain species that are being harvested for multiple reasons beyond a sustainable limit. So harvest is done intentionally for a variety of reasons. Things like traditional medicine, the pet trade, the exotic pet trade is responsible for a lot of diversity loss, many animals in the tropics, poaching and provision of luxury items and things like that for us and other things. But we also harvest unintentionally as well. So we have a lot of collateral mortality through things like fishing. Oftentimes, even though we target a certain species, we oftentimes accidentally catch species that we don't intend to. And other things, we drive down the road and we run over animals, things like that. So animals are being removed both intentionally and unintentionally from their habitats. Of course, then they don't play a role any longer in that system. Pollution. Pollution, of course, is something that is widespread today. Pollution includes both chemical and solid wastes. So we, of course, intentionally pollute the environment with chemicals through use of pesticides and herbicides and any other number of compounds. We unintentionally pollute systems through accidents such as oil spills, our urbanization and other activities result in a lot of contamination of local waterways. And we see oftentimes when solid wastes and materials get into systems such as aquatic systems, they can end up having major impacts on biota there. And there are a couple of pictures there that might break your heart. The one on the right I thought was particularly interesting. It was actually came off of a social media post from a turtle conservation society, and they had been looking at these sea turtles that had tried to swim out from the beach, but they didn't make it, and they had to come back to the beach, and many of them died. Well, they did necropsies on them, and a lot of them were full of plastic. And plastic is something we use every day. I mean, our society runs on plastic, and this is a side product of where we are today and sort of things that we use to make our lives more convenient. Invasive species and disease. Just have a few examples here. You may be familiar with feral pigs are growing in abundance across the U.S. The Everglades, of course, have been overrun with a lot of tropical snakes. The blue catfish, of course, is well known here in the Bay, and there's a lot of concern about what's going to happen with this animal. The blue catfish may be really important in preying on a lot of our native species out there, species that we rely on commercially and recreationally. Coyotes have just taken over. Okay, coyotes used to be somewhat limited because there was other big predators around, wolves and pumas and things like that, but we took care of all of them. So they're gone. Coyotes are moving in. Coyotes are now present all over Maryland. That didn't used to be. And then, of course, disease. I have sort of combined it with invasive species here because oftentimes disease is carried by invasive species, but sometimes it's not. And this figure on the right is showing disease outbreaks in amphibians from a particular disease called BD, which is caused by soil fungus, and has actually been linked to massive declines in amphibian populations around the world. One of the perplexing things about this disease is it's a soil fungus that has been around for millennia, and so have the frogs. But it's only been in the past few decades that it started to have pathogenic effects, pathological effects on the frogs. We don't know why, but what we do know is that the earth is changing. We're making a lot of changes to the earth, and very likely there are indirect and secondary effects carrying over to affect things like immunity and what have you in many wild species. So currently about a third of the amphibians, especially the frogs, are threatened today, largely because of a particular disease, which is very widespread throughout the world now, particularly in the neotropics and in Asia. And climate change. Well, of course, climate change, I certainly hope we know is related to this massive release of greenhouse gases into the atmosphere, a result of which has been warming and changing the thermal environments for the animals out there. A lot of animals out there are very sensitive to temperature changes. We oftentimes don't think about them being that sensitive because we think about things from our perspective as warm-blooded animals. We can walk around from any habitat that we find, and our body temperature is going to be the same. Most animals aren't that way. 99% of animals out there are cold-blooded. That means that the temperature affects their physiology. It affects how they work. It affects their immune function. It affects their general physiology. So there are changes in temperature. Of course, climatic patterns are varying. We're seeing instances of drought when they shouldn't be. We're seeing changes in natural fire schedules. There's loss of the ice caps and the glaciers, and of course, we're dealing with sea level rise. We're particularly focused on that around here, given that we aren't that far above sea level. But sea level rise, coastal flooding, all are things that are associated with climate change and all having one way or another an effect on the natural biota. So I talked a little bit about reasons for changes in diversity. But I want to talk a little bit now about just some specific groups of animals and give you some examples. So first, a little bit about mammals. I ran across this figure a while back, and I thought it was really sort of stunning. So what this is showing is the percent survival of large mammal species. And the black arrow shows the time that humans entered the system. And correlation isn't causation, but that's a strong correlation. It's when humans show up, diversity declines. Recall only 10,000 years ago, North America had huge mammalian megafauna, giant ground sloths, woolly mammoths, things like that, and they're gone. Combination of our activity and a changing climate at the same time was enough to take out a lot of those animals. In fact, related to this, I ran across this study. It was published in Proceedings of the National Academy of Sciences a few years ago, and I found it really fascinating, so I thought I'd present it here. Just for your interest, on the far right, that's one of those giant ground sloth skeletons. So there really were some enormous mammalian megafauna not too long ago. But around the time of the Ice Age in North America, we had the migration of the humans across the Bering ice shelf into North America, eventually into South America. And so the New World became populated by humans. And about that time is when many of these megafauna began to disappear. So if we look at this schematically, there was a time during the Ice Age when all of these large megafauna were present, that we look now, they are gone, and what we're left with are smaller animals, right? So the big animal genes aren't there anymore. So we've got the small animals, relatively small to these giant mammals that lived before. So what is the future? Well, the future has to spring from what's left, right? And so before there can be megafauna again, it's going to take millions of years of evolution, and whether or not things go in that direction is totally up in the air. But the point is, these changes last forever, and they reverberate through the systems and affect multiple species. They affect the entire shape of the biodiversity of the future. Birds. Now, this one has become has hit the popular press in the past few years. A lot of folks like birds. I like birds. There's nothing wrong with birds. But birds are obvious. We see them every day. Okay. Well, a lot of them we're not seeing anymore because over the past 50 years, there's been a huge decline in the abundance of many of the groups of birds out there today. This lower figure is showing the changes in the population sizes of different groups of birds simply since 1970. I don't think 1970 is that long ago. Anyway, in a relatively short period of time, there's been some really big changes. Interestingly enough, the waterfowl have done quite well. And that's because we've worked to protect their habitats. Wetland preservation has been a major emphasis over the past 40 or 50 years, and it worked. The problem is we're not protecting the other habitats. we're not protecting some of the things that the birds need, like insects and places to live. So this is bird population declines based on habitat types. And we see by far the biggest loss in North America has been the grassland birds. And of course, the grassland birds are typically located where our most intensive pesticide use is located in the United States. So we have large quantities of chemicals being dumped into the environment in support of agriculture. The effect is, in some cases, direct toxicity to the birds. In many cases, there are indirect effects through knocking out the insects that the birds rely on. Those insects, of course, also do things like pollinate. And so the loss of insects through chemical activities is a big problem. I'll talk about that a little bit more later. Amphibians. It's really been in the past 40 years or so that we've realized that the amphibians are declining rapidly. I showed you that picture from the BD outbreaks. Disease is a big issue. Habitat loss is a major issue. A lot of the amphibians are disappearing again in the tropics, the neotropics especially, combination of both disease and alteration and modification of the habitats. In some of these areas, as many over 100 species of amphibians are threatened with extinction. And overall, it's estimated that about 43% of the amphibian species worldwide are threatened with extinction, meaning that extinction is a possibility in the future. And of course, reptiles. The amphibians, a lot of folks got working on the amphibian stuff, and the reptile folks said, oh, you know what? Same thing's happening here too. So about 15 years ago, there was several papers that came out, started reporting on things that were happening with reptiles. I have a couple examples of some work. The one on the left was from Europe. And this is just showing the current situation for the reptiles in Europe. About 42% of them are declining in abundance as we speak. On the right is an example I found where there were some long-term studies on snake populations in several different countries, and across the board, those populations are declining. I know a lot of you probably don't get sad when you see that snake numbers are declining. The snakes are important, trust me. Fish. Well, yes, fish are having problems too. This was a paper based on, or a figure based on a paper by a fisheries biologist published in the early 2000s. And what this is showing is that it's comparing 1950 to 1980 to 2006. The upper sort of aqua number is the percentage of the high seas that are fished each year. So it's fishing effort. So there's very little effort in the 50s. Today, a large portion of the fishable ocean is being fished. And then the lower number in the dark blue is showing the percent of species that are exploited, overexploited, or collapsed. So back in the 50s, which isn't that long ago, less than 1% of the species out there that were being fished were being exploited to a level of concern. In the 1980s, about 40%. And as of 2006, it was up to almost 90%. Those numbers have not improved since then. Tuna, for example. Tuna is a major foodstuff for many of us. Tuna are in decline. Some species of tuna are nearing extinction. The southern bluefin may not have very long left at all. The Atlantic bluefin shouldn't be that far behind. Several other species, especially even those that we rely on largely for food now, the yellowfin and the albacore, are nearing the threatened status, meaning that their populations are declining to the point that they really need to be monitored closely. And the sharks. another group of fish that are somewhat popular with us humans, one way or another. But sharks have, of course, experienced some really major problems through commercial fishing, largely through the shark fin industry. So many of these shark population declines are due to these animals being pulled in and harvested simply for their fins. Oftentimes they're put back into the water alive out, which is pretty sad. So I talked, sort of been emphasizing vertebrates so far, but the invertebrates are having some issues too. So similar to the folks who've been monitoring the vertebrate populations out there, there've been people out there monitoring the insect populations and other invertebrate populations. And this was some results from a paper published in 2019 that looked at the percent decline in insect populations over the prior 10 years. So this is a 10-year period estimated, and this was across the globe for the species, the representative species that were studied. You see things like the caddisflies and the butterflies and moths having big or declining very rapidly. Across the board, the insects are in trouble again through a lot of causes, but one of the main things that's affecting them out there is our use of pesticides. Corals are another invertebrate that are near and dear to many of our hearts. And when we think of coral reefs, obviously we think of these beautiful, diverse situations like are shown here. But more and more, we're seeing situations like are shown on the right, these bleaching events. And bleaching events are largely related to elevations in temperature, but there are some other things that can cause bleaching as well. But basically, bleaching occurs when, so the coral is a symbiotic relationship between an alga and an animal. And the alga is photosynthetic, produces food that the animal uses. Well, during a bleaching event, the algae is expelled or lost, and thus the animal has no food and the reef itself dies. Some quantitative estimates on changes in coral abundance. On the left is from the Caribbean, from a paper done in 2012, showing declines in living coral cover, fairly drastic over about a 40-year period. On the right are some values based on work on the Great Barrier Reef, and there are portions of the reef, particularly the northern portions of the reef, where temperatures are warmer to start with, where a large number of the animals are dead. One of the things that I tell my students from time to time is that if you're interested in coral reefs, if you're interested in scuba diving and snorkeling and things like that, do it now. Do it now, because they won't be around forever. So this is something that your children and your children's children will not get to experience, okay, except in some very isolated situations, not nearly as widespread as they are today. So that takes us back to this question that I sort of alluded to earlier, and that is, are we really in a sixth mass extinction event? And as I pointed out, a lot of people believe that if we aren't there now, we're headed there. This is a figure that was based on an IUCN survey of literature, and the research on 52,000 species. And from that, they were able to calculate that about 13% of the birds globally are threatened, about 25% of the mammals, and about 41% of the amphibians. I mentioned that number before. I have avoided talking about plants so far because of my biases as an animal biologist, but I do have to mention that about 34% of the cone-bearing plants, cone-bearing trees, the conifers, are threatened with extinction imminently, meaning within decades. So humans, we're having the same effect, or we appear to be having the same effect as these major global changes that occurred in the past. Us as a single species are changing the planet for the biota the same way that things like asteroids from space or these giant volcanic events occur. And that, to me, I'm just stunned by that one species can alter the environment for everything else at such a level. So we kind of step back and say, how can we be so reckless? How did we get here? Why are we here? Well, a lot of it has to do with the way we address time. Now, I'm not going to wax philosophical here, but time is something that we as humans have real difficulty grasping, because time works on a massive scale compared to the way our minds work. So the way we interpret time, the way we interact with things on a temporal way, has a lot to do with our ultimate effect on biota. Of course, greed and anthropocentrism have a lot to do with it too, but we're going to focus on time. So what do I mean about our relationship with time? Well, there's an idea called the shifting baseline syndrome that was actually first mentioned by an architect in the 60s in this book called Design with Nature. Later, Daniel Pauly, a fisheries biologist, sort of reinterpreted with respect to biodiversity. And basically, what the shifting baseline syndrome means is that as humans, we're constantly experiencing a new normal. So normal is always changing. Our baseline, what is normal, changes with time. Okay, so in our experience, we're used to seeing the world around us. Okay, every generation beyond us experiences the world that we've left them, in a sense, more degraded. So to them, a more degraded world is normal. So over time, degradation occurs just as a natural extension of our experience as human beings. So basically, degradation occurs, these reduced populations and diversity of wildlife become the new normal, and as a result, from a conservation perspective, we're always shooting at moving targets, right? The baseline is always changing. An example, this is a fairly popular example, is when we look at the abundance of flying insects. Many of you, I'm looking around this room, I know you remember this, because I remember this, and we're all in the same sort of age category, is that there was a day when you drove your car in the summer that you would have to stop now and then and scrape off the bugs, right? Remember, there used to be full service gas stations, and one of the things that the gas station attendant did was clean your windshield. Well, that doesn't happen anymore. We don't need it anymore. Why? Well, because the flying insects are not around in the abundance that they used to be. Of course, from time to time, you'll drive through, say, a hatch of mayflies or something like that, and you'll experience it, but it's nothing like it was regularly in the past. So in the 1970s, this baseline for the Gen Xers, the baby boomers, was this situation where there were a lot of insects. But today, the new generations, they have not experienced this. So normal to them is a degraded state. Okay. So when normal is a degraded state, and with each generation, it becomes more degraded, then it's almost just guaranteed that that things are going to continue to get worse. So really what it comes down to is this incongruity between our lifespan and our impacts on the environment. Okay. There are some of our effects that are really easy to recognize. They're immediate, they're obvious, and we respond to. Okay, oil spills. It happens, we pour resources into it, we get out there, we try to fix it. Okay, most things don't occur like that. Most of our impacts are very slow to emerge, and they are sustained over long periods of time. For example, the situation with global warming. Over the past century, the global temperatures changed a couple degrees. You know, doesn't seem like that much from a human framework. But we know that this is going to continue over many years and have ultimate impacts. So basically, the situation we have is that we're changing the environment over long time scales. And because they operate on these time scales, they're very subtle, and to us, they're very easy to ignore or just to simply miss. And that, I think, is one of the major problems that we face today, is that we are myopic, we are short-sighted. We do not look beyond where we are today. We do not look beyond our own lifespan or our children's lifespan. The things we're doing to the environment are lasting on that sort of time scale, but we're not responding to them now because it's out of sight, out of mind. So just to summarize, abundance and diversity of wild animals and plants is declining across the globe, associated with habitat alteration and loss, pollution, exploitation, harvest, global temperatures, climate change, human population density and consumption. Basically, it's the human footprint. Okay, it's the things that we do through our daily lives that are changing the systems around us. And I think this is a pretty good representation of the human footprint here. It's a very nice correlation between human population size and extinction rate of wild animals. That's where I'll leave it. So thanks for listening, and I'm happy to take any questions.